All right, so the lab this week, we're concluding our lab on motion with constant acceleration. So we are again using those kinematic equations. We're making predictions, we're making graphical predictions, but also in this particular lab, we're doing equation predictions. So you will be applying those skills you learned in lab 2 and 3 to make those graphical predictions again, and then you're going to take another video just like you did in lab 2 and 3, and you're going to graph that out. That's the summary aspect of this lab. The only new aspect of this lab, the first activity, we're going to be using those kinematic equations symbolically. Okay, so now what I mean by symbolically is you're going to be solving for delta t and final position, but without numbers. Okay, so just using equation form. So this is something we often require, that when you turn in your homework, you're displaying your algebra with no numbers, because it's much easier to find mistakes that way than it is if you put your numbers in. So then we will, of course, use some provided numbers to calculate that. The next thing we're going to do is open up a simulation to check your algebra. Okay, so we're going to use this projectile motion simulation. It opens up similar to, let me see if I can open it up. So if you click on the link, you'll open fetcolorado.edu, and you're looking for the projectile motion simulation. Now notice you could download this, or you could run it right from the web browser. So we'll go ahead and run it right from the web browser by clicking the play button. We're using the intro version. And what's cool about the intro version, it's going to start out at the particular height, and you can look at the velocity and acceleration vectors. So I'm going to go ahead and fire apparently a pumpkin. I could do a pumpkin or a cannonball, anything that you want. In our case, it really doesn't matter because we do not have air resistance. So this air resistance button should be unclicked. Go ahead and fire the object. And of course, it is showing the trajectory or the path that the object is taking. And we ultimately want to measure the distance that the object traveled. So we have two tools here that we could use. We have a tape measure. So we can go ahead and put that tape measure. I'm going to lower this down so I could find exactly where it started. I'm going to put the X this orange X here, right at the starting point, and this other X is going to be at the ending point. So let me raise this up a little bit so it is on a straight line. So that is one way we can measure the distance that the object has traveled. The other way we could measure the distance the object has traveled is using this tool right here, where it tells you the range and the height and the time. Notice that when you hover over a particular data point, the data point highlights. It tells you are reading the total time in the air, the total range it traveled, and the height of that particular data point. I'm going to go ahead and reset that simulation, and you can see that by pressing this reset button, everything goes back to the original values. So keep in mind the way to move the cannon up and down is just by clicking on the cannon itself and dragging it. The way to change the initial speed is just by clicking on the lever here and dragging it. And you can change your different object. If you wanted to throw a piano, that would be fine, and you don't have to have those velocity vectors on, but it would be interesting. This activity 2 shouldn't take you all that long. I did want to point out that the discussion question is going to focus on your results from the simulation. So you might want to just check out what that discussion question is asking kind of ahead of time, just so you're prepared for that. I'm going to zoom in on the FET for a minute. Let me So a few things you're going to do, of course, you're going to calculate the final position, okay, from your equations, from your kinematic equations. So you're going to have a prediction of where an object should land given an initial height and an initial velocity. Okay, so a few things that you can do is there's a target associated with this, and you can actually slide that target around. You could put that target at your predicted value. And then you're going to use this tape measure. The tape measure lives up here, so you're going to pick up the tape measure and you're going to drag it down to the bottom. You guys can see my little pencil moving, right? Okay, good. So you're going to drag it down here. There's a red cross right here, and there's a red cross at the other end. And that tape measure is going to display the distance between those two red crosses. All right. So, and I mentioned that the discussion question is going to ask you a few things. In particular, it's going to ask you, well, what would happen if you had air resistance? So for that discussion question, you would check the little box for air resistance, and then it has a whole bunch of different objects that you can toss under air resistance. So that's kind of what you're going to look at. If the simulation gives you a different value than your algebra, that's a really good indication that there's a problem with either your calculation or your algebra. So don't just continue on and say, oh, the simulation's wrong, because it's more likely that you should go back and recalculate your predicted value, okay? And like I mentioned, activities 3 and 4 are pretty much a recap of what you've done for the last couple of labs, and it's intended to be this summary of motion.
So you're going to make predictions of a ball that's rolling off a table and landing on the floor below it. And make sure you analyze the data just after it leaves the table and just before it hits the floor. Don't forget to check all the boxes on your checklist for predictions. What most people forget are the title and the axes labels on your prediction sketches. In activity 4, you're going to take a video of an object in projectile motion, just like you did in the last few labs. If you can't take this video, the Vernier Video Analysis has a video you can use. It is called The Ball and Table. When you first open up Vernier Video Analysis, you can scroll through the sample videos and look for the one that says Ball and Table. It has clearly marked scale, and of course the ball is rolling off, and you shouldn't start taking data until the ball has left the table.
And here's the discussion prompt. I kind of mentioned it already. So you predicted the final horizontal position of an object, right? So basically you calculate where it should land. And how do you think this landing point would change if there was air resistance? And what if you chose one of the other objects? So the different objects, you can have cannonball, you can have tank shell, golf ball, baseball, football, a pumpkin, a human, a piano, or a car. So, and then just kind of discuss about that.